I have two extra examples on page 61 and 62. The first one is pretty long, A through F. Let me go over the first three in this video and come back into the other three. We have a position function, S of t, to be this cubic function. Part A wants us to find the velocity function. You know that velocity function is the first derivative of the position function. So let's take the derivative of this gray highlighted function. Okay, so t cubed will give us 3t squared minus that will give us negative 12t. Now lastly, this plus 9t, the derivative is plus 9. We don't have to factor this, but I'm looking at this and I notice that all of these are divisible by 3. So I'll factor out the 3, and that will give me this. And I'm looking at it, I'm like, oh, that can be factored out even further, right? That trinomial, we can write this trinomial as t minus 3 times t minus 1, right? So they never asked, but it factors very nicely, so I went ahead and factored it. But if you stop here, like over here, that's still correct. This is just factored out, okay? Same thing. All right, they want us to find the velocity after 2 seconds. So what I need to do is plug in 2 into this velocity function. If you have a calculator, you can plug that in, but I don't want to like multiply by big numbers. I'll just plug it into this factored out version, okay? So I'll do 2 minus 3 times 2 minus 1. So I get 3 times negative 1 times positive 1. The velocity after 2 seconds comes out to be negative 3 units per second. Now, what does that negative velocity mean? This negative velocity means this particle is moving backward right now, okay? So interesting, right? It's not always forward moving particle. It can go backward, it can go forward. So who knows, maybe a couple seconds later we end up where we actually started from, okay? All right, now, when is this particle at rest? For this type of problem, whenever I ask you to find the particle at rest, I'm asking for when is the velocity 0. So set that velocity equal to 0. Now I think I'm going to go ahead and use this factored out one because that's going to make it very easy for us. Look, I'm going to set this equal to 0. Okay, and let's solve for this. When is t minus 3 equal to 0? When time is 3 seconds. When is t minus 1 equal to 0? Well, when time is 1 second. So this interesting little particle is stopped, okay? So like if after, like, you see, if I were to, maybe I shouldn't, but like, let's say these are the times, okay? 0 second, 1 second, 2 second, 3 seconds. It's like moving, okay? I shouldn't do this. But what happened is that after running for about 1 second, this particle stops. It takes a break, okay? And after 1 second, it moves around again, right? But after 3 seconds, at 3 seconds, it takes a break again, is at rest. So that is what we can figure it out by setting the derivative equal to 0, okay? All right, after 1 and 3 seconds. Now, let's look at the next part. When is this particle moving forward? So that's very interesting because what we just found out is that, like, here is time 0, right? We start at time 0 second, 1 second, right? 2 second, 3 second. I'm just making up a timeline. 4 second, and so on, right? What happened over here is that we know this particle is at rest at 0 seconds. So it stopped right here, stopped. After 3 seconds, it stopped again, stopped. Now, what else did we know? Didn't we find out that at 2 seconds, okay, take a look at that first part that we did. After 2 seconds, we concluded that this particle was moving backward, right? And we'll go ahead and write that down on this timeline. It was moving backward. And how did we figure that out? Because the velocity was negative, okay? So the particle is moving backward in between 1 and 3. Because listen, think about this. This makes very good sense. Um, it doesn't stop in between 1 and 3 seconds, right? It never stops. Because if they stopped, then we would have been able to solve that for that second when we are solving for B. We know this particle is stopped only at time 1 and time 3. So if it never stops in between 1 and 3 seconds, it's just keep moving backward here, right? In this interval. So what I want to know is what this particle was doing in between 0 and 1 second and after 3 seconds, because this particle never stops um, after 3 seconds or before 1 second. So what I'm going to do is I'm going to figure out the sign of the velocity here. It's what's a good number that we can plug in between 0 and 1? I'll say like half a second in. Let's see what this particle is doing, moving forward or backward. I'll figure it out by plugging in a test point of half into this velocity function. So if you do 3 times half minus 3 times half minus 1, now we really don't need an exact value, we just need a symbol, like a sign of this number, right? So we're doing 3 times, now look, if you do half minus 3, that's a negative number, right? Where did that go? Let me share that again. And the second subtraction was, come on iPad, give me 1 second, I have to type this code in. Oh, here it is. If I do half minus 1, that's also going to be negative, right? So positive 3 times negative, that's going to be a positive number. So what we know is that the particle is moving forward when it first starts, it's moving forward, but it's going to be stopped at 1 second and it's going to go back. Oh, I forgot something. I'm going to go back. Maybe slowly. After 3 seconds, it's going to stop. So I wonder if it's going to be moving forward or backward after 3 second mark. So let's just plug in another number after 3 seconds. I'll plug in 4. Okay. So if I plug in 4 into the velocity function, I will get 3 times 4 minus 3 times 4 minus 1. That is 3 times 1 times 3. If you multiply 3 positive numbers, you get a positive number, which means the velocity is positive. So we know that this particle will be moving forward after the 3-point mark forever and ever and ever. Never comes back. Never stopping after it, never going backward. Okay? So when is this particle moving forward? In between 0 and 1 second, and 3 point after 3 seconds and on. So like 3 to infinity. So that will be the answer in interval notation. But I can work this out, write this out as in between 0 and 1 second and after 3 seconds and on. Okay, so that is when this particle is moving forward. It's a long problem, okay, because I only did half of it. But I'll stop this video and I'll come back and try to record D, E, and F a little bit later. But I think I'm actually going to jump to some chapter 2 problems, and then I'll come back and do the other parts later, because these were just extra examples. We got to get to module 2 now, okay?